Hello there, welcome back to Technology Innovation Hub. So it's going to be the 22nd session on Oracle architectural journey. Let me share the screen. So we have been learning Oracle redo-log buffer, and the last session was about checkpoint synchronization and commit and DB writer, and finally we discussed the conditions for log writer to write to the redo-log file, from the redo-log buffer to the redo-log file. So that was the last explanation. So let's continue from there, and let's take a look at a scenario in order to further understand this commit mechanism and the checkpoint mechanism and the DB writer a little bit further. Now in this document you can see if you get a table. Now for this scenario we need to have a very small table with a one column. Now we know a table object. A table is an object in the database, logical object, and it locates in a schema. Now if you take a look at this one, if you consider this outer the blue circle as the Oracle database. Oracle database normally consists of physical, in the physical structure, it has control files, redo-log files. This is what we have been learning now. And we have DBF files. And on the logical hierarchy, as I explained earlier also, we have the highest component in the logical hierarchy, that is a table space. So table space is nothing much, physically collection of database files. DBF files comes under physical structure, table spaces comes under logical structure. So for minimum requirement for a table space is at least one DBF file. Now ultimately this table, let's say there's a table called employee EMP, it has to be located in one of these table spaces, because table object is a object belongs to a schema. That is, a schema is nothing but set of objects belongs to a user. When you say create user A, what will happen? I mean, user get created, and when you create the first object, maybe a table or index or whatever, and the schema get created. That's what's going to happen, and it will start claiming the space whenever you insert the record. So start claiming the space from where? So that's why, because schema belongs to a table space. Then table space, within that we are going to have DBF files. So ultimately your table object is going to locate in one of the DBF files which belongs to the table space. So let's say if you are working with the schema A, that is user A is in user's table space, So within the schema, the employee object is there. And for the user's table space, we have 3 DBF files. So in either of the DBF files, the EMP object will be located in a sense, it will claim space from either of these DBF files. That is how it's going to be. But it's located on schema A within the table space user. So that is how. So our table, now we are going to create a table called EMP. No? So EMP, create a table with only one column. Okay, just let's say employee number, whatever. And we are going to insert 1 million rows. Now this is our scenario. Now 1 million rows, we are not going to give any commits. We are going to give a commit at the end of the 1 million rows only. There is no in-between commits are there. There is no in-between commits. And at the end only, we are going to give the commit. Now in that scenario, see what's going to happen. At commit, we know it's a one condition. It's just only a single condition for log writer to fire. And we have learned 13 conditions. In the previous lesson, we mentioned there are 13 conditions. So whether a commit is given or not, now since it is 1 million, means continuously insert operations are happening. And so that changes should be taken place in the redo-log buffer. So yeah, I mean the records are coming to the buffer cache, and since it is a DML command, for each record there will be a change. Change means the insert. It should be tracked in the redo-log buffer. After certain time, redo-log buffer will get filled, and we have other conditions when there is 1 MB of redo, when the log buffer 1/3 full. So due to those reasons, anyway, data is going to get flushed from redo-log buffer to redo-log file, even though the commit is not mentioned. Now that is what's happening in our between the log writer and the log buffer. That is happening there. On the other hand, now since this continuous insertion of data is taking place in the buffer cache also, it might run out of space, or certain records can become LRU and all that can happen. So then what's going to happen? From the data buffer cache, DB writer will start flushing due to the conditions. When there is no pre-buffer, there are conditions for DB writer to write. So due to those conditions, DB writer will write the relevant records due to this insert. The records which are getting inserted, it will temporarily flush those records to where? To relevant data files. So if the EMP table is claiming space from a.dbf file, then DB writer will claim space from there and it will update the data information. As records are coming in, so insert data will be updated by claiming space from this a.dbf file. So as a result, the size of the a.dbf file may gradually increase. If it is almost run out of space, it will keep on increasing. We can monitor that. So that's the scenario. So on one hand, it keep on flushing to the redo. On other hand, temporary, the DBF files are getting updated because this is a little bit of large one, 1 million rows. We can increase, but this is just a testing scenario, 1 million rows. Now, at the end, the commit. At the end, the commit. Insert 1 million rows, give the commit at the end. So DBF file will go, log data fire due to other conditions. That's all. So now, at the end, commit means what? We are going to end the transaction. Now, what is our situation? We have data already flushed to the DBF file due to the other condition, because DB writer, log writer, DB writer is firing independently, and we know whenever DB writer fires, log data has to fire. Before DB writer writes, log data has to fire. So now look at the synchronizations. From one hand, the redo log buffer information is being cleared to the redo log file. So SCN numbers are there, system chain numbers are there. So same set of SCNs being system chain numbers due to our insert transaction, it is being cleared to the DBF files. Now, but in the DBF file, data is there temporary. But now the commit comes at the end of 1 million rows, the commit comes. So then Oracle will get to know, the transaction table will get updated. Okay, now this transaction ends. Transaction ends, and that particular SCN will be marked in the transaction table. So now what's going to happen? When the next checkpoint takes place, Oracle has to sync up these two files. It will take a look at the redo log mechanism, and it will take a look at the redo log file, and it will check at which point the commit happens, and it will compare the SCN numbers, set of SCN numbers where in the DBF file, and then what's going to happen? It will sync up with the it will confirm, it will inform the DBF file, okay, now these things are committed, you please confirm this data. It's no more temporary because the commit has been happened. So, and the checkpoint will do the synchronization. So that is the situation at a higher level. What's going to happen if such a situation in such a scenario? But there can be questions like this. Now, for example, now let's say we have the redo log files. Now this fellow from redo log buffers keep on writing here. Now let's say if there's a situation like this, now we are not going to give a commit. Continuously we are keep on flushing. And in such situation, let's say now this file will get filled, 50 MB will get filled. Let's say the size is small, let's say 10 MB or something. So it will do a log switch. And it will come here. It will do a log switch again. Now, when it's try to overwrite, what's going to happen? When it's try to overwrite, now since there is no commit, there is no issue, because the checkpoint may or may not now to override what is the primary condition. Primary condition is the checkpoint should be completed. No? To override the checkpoint should be completed. Now, in our case, the commit takes place at the end of 1 million rows. It is keep on, due to the, let's say, even more than 1 million, our DML, it can go across the cycle. That doesn't matter, because due to a huge insert operation, it can cause to kill this one. It can cause to kill this one, and it can cause the last one, and this it will come and try to override. So it is allowed. Because why it is allowed? Now this is not, since it is not committed, checkpoint will complete. That's okay. The problem is if the data is committed only, it will wait till the checkpoint completes. So therefore, for this particular transaction, there is no harm for Oracle log writer to spread the data across the log files. There is no harm. Fine. So ultimately, when the commit happens, it will nicely do the synchronization because the DBF file, the data is temporarily available for him, and it can compare the SCNs and nicely it can do the sync up. Fine. So that's just a small scenario for you to understand the theories that we have explained, and we can do these things practically as well. But I think in the architectural level, let's not go to that level of doing hands-on. We do these things under tuning. You can understand those practicals and do the hands-on under tuning redo buffer and redo setting the optimal log file sizes. So and tuning the buffer cache. So under those scenarios, so we will discuss those things with hands-on. Good. Okay. So let's continue to slide. And this is where we talked. Okay. Yes. I think this is the last slide that we have to do on redo log explanation. So this is what Oracle uses pass commit mechanism to improve performance. Pass commit mechanism, that is a log writer. Oracle assigns a SCN. We know that system chain number for every transaction. With commits, log writer writes a record along with the SCN to the current log file. That's also we know. And an entry is made to the transaction table claiming that commit. That's why whenever commit happens, normally transaction table tracks all the SCN, but it claims a commit when it claims the SCN. When a commit happens, that particular SCN is marked as committed. So that's what it means. Okay, transaction table. So it is tracking all the transactions. When activity is high, log writer can use group commit. So that is something because now log writer has to keep up the trend, because heavily data is coming in from the redo log buffer, continuous streaming is coming. So log writer has to keep up that speed. So that's what, in order to keep the performance, when activity is high, log writer use group commits. For example, when a user commits a transaction, log writer writes it to redo log disk, holding the subsequent writes till the previous commit, finishing the updates to the disk. That's right. Because when a commit happens, it has to complete that plan. And it will hold the rest of the operations. That's what it says. For example, when a user commit the transaction, causes log writer to write. Definitely it's going to update because commit is a condition for log writer to update from data from redo log buffer to redo log file. So this will hold the subsequent writes because it has to complete that particular operation, log writer. In this case, once that operation finishes, log writer will update the log files for uncommitted data in one operation. So that is to speed it up because there's a hold. So rest of the uncommitted one is has to, because there are other conditions. No? Other conditions are there for log writer to write from redo log buffer to redo log file. If commits are continue to be high, so if it still is continuing, a lot of commits are coming, and high, every write by log writer contains multiple commits data. If commits are continue to high, every write by log writer can contain multiple commit data. This way, log writer will keep performance at high. So just about under performance tuning, we can discuss these things because we cannot parallelize log writer like DB writer multiple processes. We can't define log writer 01, 02 likewise parallel log writer processes, because DB writer is possible, but log writer is keeping it up, and it can do it because the size of the redo log buffer is small, so it can keep it continuously in this way. Group writes, group commits, so those things are there. So this is the documentation. You can take a look at this reference for this one. It explains, and you can go there. But I think it's the same thing what we just explained. Yes, you just take a look at that one, the group commit, and all fine. Okay, so that is going to, I think, end our log writer explanation. Yes, so this is the same thing. So that's going to end our log writer explanation. So up next we have the data buffer cache. Data buffer cache, let's start in a new session. So this is what we have up next. So it will be deeply explained like the redo log buffer, data buffer cache. Also we have a lot to learn. LRU list and checkpoint queue, a lot of things are there. So let's learn it. And hold in, hot and the TC algorithm. So there are things. So let's do it in the next session. Fine. So I'll stop it from here. If you like the video, you can put a subscribe, and I'll meet you soon in the next session. Have a great time. Bye. Bye. Bye.